Okay, we're going to start off with an intro to dilations. And dilations can either be an enlargement or dilations can be a reduction. There is also what is called the center of dilation. So if you think about an enlargement and you put an item on a copy machine and you quote unquote blow it up, it's going to enlarge and you're going to put in like 150 or 200%. If it's a reduction, you're going to put in something smaller than 100%. So we have what is called a scale factor. And I will always use scale factor with the letter K, but just FYI, your book uses N. I do not know why, but I will always use K. So if you have an enlargement, your scale factor has to be greater than 1. And if you have a reduction, your scale factor has to be less than 1. So if you have a scale, less than 1. So if you have a scale factor that is 1/3, is that going to be a reduction or an enlargement? If you have a scale factor that equals 5/4, is that going to be a reduction or enlargement? You should have found that this is going to be a reduction because 1/3 is less than 1. You should have found this to be an enlargement. A lot of people will look at this as saying, hey, it's a fraction, so it has to be less than 1. But it's 5/4. So this is the same thing as 1 1/4, which means that it's greater than 1. So it is an enlargement. So if we're talking about scale factor, a lot of times you'll see it in either decimal form or you see it in fraction form. When we have talked about the other transformations of rotations, reflections, and translations, all of these were congruent transformations. And they were congruent transformations because whatever figure you had to begin with, when you reflected it about a line, the figures were exactly the same. They didn't change size, didn't change shape. Same thing with the translation. Translation, if we slit it to the right and then down, it's still going to be the exact same shape. However, a dilation is not a congruence transformation. Dilation is not a congruence transformation. And what it does, though, is let's say we have a 30, 60, 90 triangle, and you quote unquote blow it up or enlarge it. It is still going to be a 30, 60, 90 triangle. So even though a dilation is not a congruence transformation, it does what's called preserves the angles, which means that the angle measures do not change. it's the length of the sides that change. So for example, if this had a scale factor of, say, 2, so this would be 3, so this is going to be 2 times it, which would be 6. If this were 5, this would be 2 times it, which would be 10. And if this were a 4, this would be 2 times it, which is an 8. Okay, so that it does preserve the angles, and the scale factor is seen on the sides.